Hi to all, welcome to DC Missions Multiple Choice Questions. This video may be helpful for GATE competitive examinations and other competitive examinations like RRP for electrical engineers. The DC Missions Multiple Choice Questions, one by one we'll discuss now. Coming to the first question, if the field current is decreased in DC shunt motor, the speed of the motor, options are A, B, C, D. A remains same, B increases, C decreases, D none of the above. What is the relation between field current and speed is inversely proportional. If the field current decreases, flux will decreases, hence the speed will increases. B is the answer for first one, because speed is inversely proportional to flux in case of DC shunt motor. If the field current decreases, the speed will increase. That is, B is the answer for first one. Coming to second question, in DC mission the shape of main field flux distribution is, it is very important question. The DC mission shape of main field flux distribution is A triangular, B flat tapped or trapezoidal, C saddle shape, D peaky in nature. The main field flux is produced by poles and field winding is wound on DC mission. The main field flux distribution is flat tapped or trapezoidal wave. That is the answer. B is the answer for second one. Flat tapped or trapezoidal flux shape of the flux is. Coming to third question. In DC mission, shape of armature MMF is, the shape of armature MMF is triangular in nature and directed towards the brush axis. Brush axis means it is MNA, magnetic neutral axis. In DC mission, shape of armature MMF wave is A triangular and directed towards brush axis. A is the answer. B triangular and directed towards main pole. C saddle shape. D peaky in nature. A is the answer for third one. Coming to next question, what is the coupling field used between electrical and mechanical system in energy conversion devices? What is the coupling field we are using in electromechanical conversion devices? A magnetic field, B electric field, C magnetic field or electric field, D none of the above mentioned. Magnetic field and electric field, magnetic field and electric field both we can use for conversion of electromechanical conversion. C is the answer for fourth one. Coming to next question, the magnetic flux density has the unit of, what is the unit of magnetic flux density is Weber, ampere turn, C ampere, D Tesla. A Weber is the unit for magnetic flux, whereas magnetic flux density unit is Weber per meter square. But options they didn't mention Weber per meter square. Tesla Weber per meter square is also called as Tesla. Tesla is the unit for magnetic flux density. Hence D is the answer. Coming to next question. An electromechanical energy conversion device is one which converts electrical energy into mechanical, B mechanical energy into electrical, C electrical to mechanical and mechanical to electrical, D none. An electromechanical conversion device is one which converts electrical to mechanical and mechanical to electrical. A machine, maybe a generator or a motor. Hence C is the answer. The energy storing capacity of magnetic field is about how many times greater than that of electric field? Normally, the energy storing capacity of magnetic field is 25,000 times greater than electric field. Hence, all the electrical machines, the energy conversion medium is magnetic field. Magnetic field is 25,000 times greater than electric field. Hence, B is the answer. Coming to next question, the armature of DC generator is laminated. A to reduce the bulk, B to increase the strength, C. To reduce the eddy current losses. D. To reduce the copper losses. The armature of DC shunt generator or DC generator is laminated to reduce the eddy current losses, because the eddy current losses can be minimized by using laminated structure. C is the answer for 8th one. Coming to next question. The insulating material used between commutator segment is normally A. Graphite, B. Paper, C. Mica, C. D. Insulating varnish. Normally, commutator segments are separated by using mica. Graphite, paper, mica, insulating varnish, all are insulating materials, but mica has more insulation strength and easily placeable between commutator segments. Hence, we can use mica as a insulating material used in commutator segments. Coming to next question, commutator pitches of duplex and simplex lap windings are respectively. Commutator pitch means the distance between two commutator segments is known as commutator pitch. For duplex, commutator pitch is 2 and simplex lap winding is commutator pitch is 1. Hence, A is 4 and 2 is wrong answer. B, 2 and 1 is the answer. Commutator pitches of duplex winding is 2 and commutator pitch of simplex winding is 1. It is defined as distance between two ends of same armature coil are connected. So, the difference in duplex winding are 2, as there are 2 turns in the duplex winding. Hence, B is the answer, 2 and 1. Coming to next question, iron loss in DC machine are independent of variations in A. Speed, B. Load, C. Voltage, D. Speed and voltage. Iron losses in DC machines are independent of variations in speed, load, voltage, D. Speed and load voltage. Among these, speed, load voltage and speed and load voltage. Iron losses are independent of load because the load is not responsible for iron losses. These are constant losses. Whatever be the load, these losses will appear. And speed and voltage. B, load is the answer because the iron losses does not depends on load and depends on speed and voltage. Coming to next, a 4-pole DC generator provided with 2-layer lap winding with 16 coils. The pole pitch will be, pole pitch means distance between two adjacent poles or number of slots divided by number of poles gives pole pitch. A 4-pole DC generator provided with 2-layer lap winding with 16 coils. 16 coils is a 2-layer. 2-layer means 16 into 2, 32 divided by 4. 32 divided by 4. The answer is B, 8. 32 divided by 4. Answer is pole pitch will be 8. B is the answer. Coming to next question. A DC generator, when the number of poles and the number of armature conductors is fixed, then which winding will give the higher EMF? Higher voltages will be provided by using lap winding, wave winding, either A and B, or depends on feature of design. For higher voltages and lower currents, we go for wave winding, whereas for higher current and low voltage, we go for lap winding. Hence, B, wave winding is the answer. Coming to next question, mechanical losses are primary function of A, current, B, voltage, C, speed and D, none. Mechanical losses are primary function of speed. Based on speed, this will depends mechanical losses. Hence, C is the answer. Coming to next question. Fleming's right-hand rule regarding direction of induced EMF correlates. Fleming's right-hand rule used for generator. Magnetic, if you provide your right hand, then magnetic flux, direction of current and flow under resultant force. Magnetic flux, direction of motion of the direction of EMF and induced EMF. Magnetic field strength, induced voltage and current. C. magnetic flux, direction of force, direction of force and direction of motion of conductor. Fleming's right hand rule, the thumb indicates forefinger indicates magnetic flux, whereas thumb indicates direction of motion of the conductor and middle finger indicates EMF induced. Hence B is the answer. Magnetic flux, direction of motion and direction of EMF induced. B is the answer. In lap winding, the number of brushes is always. In lap winding, the number of brushes will be always double the number of poles, same as the number of poles, half the number of poles, D2. In lap winding, A equal to P. Number of parallel paths equal to number of poles. Hence, in lap winding, the number of brushes is always in lap winding, the number of brushes is always number of poles, same as the number of poles, because in lap winding A equal to P and it is equal to brushes. But in wave winding, number of brushes required is 2 because only 2 parallel paths are there. Hence answer is same as number of poles. B is the answer. In a DC generator without commutator is a DC generator without commutator is a AC generator, B DC motor, DC generator, D is induction motor. Without commutator, a DC generator may be called as what is the purpose of commutator is to convert AC into DC. If the commutator is absent in DC generator, then it acts as AC generator. A is the answer. In a DC machine, 72 number of coils are used. Find the number of commutator segments. Commutator segments is equal to number of coils actually in case of DC machines. In DC machines, number of coils equal to number of commutator segments. Hence, A 36, B 37, C 72, D 74. 72 number of coils are there. Hence, 72 commutator segments we have to use. Hence, C is the answer. Coming to next question. Mechanical losses are primary function of current. Mechanical losses are primary function of voltage, B current, C speed, D none. Speed is the answer. Mechanical losses are primary function of speed. In lap winding, the number of brushes is always double the number of poles, same as number of poles, half of the number of poles, D2. In lap winding, the number of brushes is always equal to number of poles. If the field current decreases in shunt DC motor, the speed of the motor increases. That already we discussed in the previous. Coming to next question. The EMF induced in the DC generator armature winding is, the EMF induced in DC generator is AC actually, because by the use of commutator we are obtaining DC. Initially, inside of a armature of a DC generator, it is alternating current. Hence, A is the answer. Coming to next question. Commutator in DC generator is used for, already I told you, it is used to convert AC armature current into DC armature current. That is D answer. Coming to next question. In DC machine, yoke offers A. Mechanical protection to the machine, B. Flux path completion, C. Produce working flux, D. Both A and B. The purpose of yoke is not only for mechanical protection, both flux path also. It acts as return path for flux, hence D is the answer. Both A and B, D is the answer for that. Which of the following windings are necessary in case of all DC machines? In all DC machines, which type of windings we are using? A. Closed winding, B. Lap winding, C. Wave winding, D. Open winding. In all types of DC machines, it is very important to note that all the DC machines have exactly closed windings, whereas AC machines have open windings. In DC machines, we are using commutator and brushes. We are using brushes. As brushes we are using, it is a closed winding, not open winding. Hence, A is the answer. In DC machine, 4-pole lap winding is used. The number of parallel paths are A2, B4, C1, D8. In DC machines, which type of winding is 4-pole lap winding is used? Number of poles are 4, hence the number of parallel paths are in lap winding or number of parallel paths A equal to number of poles P, hence A equal to P. Now answer is B, 4 is the correct answer, because in A equal to P in lap winding, hence number of parallel paths also equal to number of poles, hence B equal to 4. Answer is B. Coming to 28 question. The wave winding is preferred for which of the following rating? The wave winding is preferred for which of the following rating? Wave winding, I already told you which type of winding it is used for high voltage and low current. Hence answer is high, low current and low voltage. B is high current, high voltage. C high current, low voltage. D low current, high voltage. D is the answer, low current and high voltage. Wave winding used for low current and high voltage. Hence low current and high voltage, D is the answer. Next question. A motor is a machine that converts A mechanical energy into wind energy. Now a motor is a machine that converts electrical energy into mechanical energy. B is the answer. Coming to the construction of DC motor is similar to DC generator, AC generator, D transformer, A mechanical engine. The construction of DC motor is similar to DC generator. The construction of a DC generator and DC motor both are same. If you give electrical energy, it converts. If it converts mechanical energy, it is a DC motor. If you give mechanical energy, it converts mechanical energy into electrical energy. Hence, it is called DC generator. DC generator and motor constructionally both are same. Hence, B is the answer. Coming to next question. A motor works on the principle of A. Electromechanical energy conversion, B. Electromagnetic induction, C. Fleming's right hand rule, D. Fleming's left hand rule. A motor works on the principle of electromagnetic induction. The principle of electromagnetic induction is used in motors. Whenever current carrying conductor placed in a magnetic field, it experiences a mechanical force. That is principle of a motor. A motor works on the principle of electromechanical energy conversion, electromagnetic induction, C. Fleming's right hand rule and left hand rule. Left hand rule and right hand rule used to find the direction of motion of the conductor, current direction and magnetic field direction. But B is the answer, electromagnetic induction. Coming to next question. When a conductor carrying a current is placed in a magnetic field, a force is produced on that. A force will be induced on conductor when it is placed in magnetic field. That is the principle of motor. C is the answer. Coming to next question. In case of DC motor, the induced EMF is known as armature reaction, B back EMF, C reactance voltage, D all of the above. In case of DC motor, the induced EMF in armature is known as back EMF. Back EMF is the counter EMF. B is the answer. Coming to next question. The back EMF induced in motor is due to motor action, B due to generator action, C due to engine, D all of the above. Due to generator action, the back EMF is induced in motor. Coming to next question. The terminal voltage equation of the motor is given by motor voltage equation. Terminal voltage equation is V equal to EB plus IRA, V equal to EB plus voltage drop of armature, V equal to E generated plus IRA, D both A and B. A, V equal to EB plus IRA, V EB plus voltage drop armature, C E gen plus IRA. Now D both A and B are answers.